Hello viewers, my name is Raj and welcome to my YouTube channel. In this video we will talk about, this is a new video in complete placement preparation series, and in this video we will talk about Leetcode 53, which is maximum subarray. So let's go towards the problem and understand what the problem statement says. So if we see in this particular screen, the Leetcode has tagged this particular problem as easy problem. And the problem description says is we'll have a list of numbers which is a contiguous subarray, sorry, which is a contiguous array, and we have to find the sum of particular numbers, some set of particular numbers which are contiguous in nature, and their sum is maximum. So what I meant to say is, let's say I have this particular array, and if I sum this thing, if I take the sum of all the contiguous numbers, I will have a certain number. But what I want is, I want the maximum sum of the elements which are present in this particular array. So if I see clearly, there are some negative numbers as well. So if I add this particular all the numbers contiguously, then the actual sum might not be the maximum one. So, but if I take a certain section of the particular sub array or of the array, then that particular sum might be greater than the sum of all the numbers. So the idea is to get the maximum sum of the contiguous elements. So here contiguous elements is the key. So the numbers should be contiguous. So let's say if I take in this particular example, let's say if I say this particular subarray where 3, 4 and -3, 4 and -1. So if I sum this thing, it will be equal to 0. And similarly, if I continuously take this particular sum, 4 minus 1 and 2, this sum will be 5. So which again, so 5 is greater than 0. So 0 was not the maximal sum. Similarly, this was the combination of 3 elements, right? But I can take the combination of 4 elements, or I can take the combination of 5 elements, and I can check all the sums, and I could compare and somehow get the maximum sum this array can have. So how to code this particular thing? So if I logically see this thing, the one thing that I get in my mind is to have each and every possible combination of the contiguous elements, and then try to get the sum out of it and see what's the maximum sum that I can get, and report that particular sum. So since I don't have to return elements, I have to just return sum. So what I can do is I can try some looping codes, write some 2 or 3 loops, and I can simply get the result. But if I see that looping thing, I have to write 2 loops for iteration, for getting the particular I and j of the starting and the end point of the subarray, and one other loop to get the sum. So this will be again a 3 nested loop. So it will be an order of n cube. So if I logically see, whatever our conventional logic is, the conventional logic will give an output. Wait a second. Will give the computational time complexity of order of n cube. So n cube is a big thing, or a big time complexity to deal with, and the space is not an issue. So space complexity will always be 1, because again we are doing this thing using some 1 or 2 variables. So space complexity is never an issue in this particular case. But the time complexity is a genuine big issue that we have to deal with. So somehow we have to reduce this particular thing to order of n, or the most efficient one, let's say order of n log n. I'm just saying, I'm not like telling the answer. It is just a logic that we always follow, that we have to somehow try to reduce the time complexity to the lowest possible time complexity that we have. So to achieve this thing, we will use this particular algorithm, which is known as Kadane's algorithm. So this is known as Kadane. So Kadane. So this particular person, or I don't know if the name is Kadane or what. So this algorithm says is, whatever this array I have, whatever the array I gave into the in this particular thing as an input, in this algorithm as an input, I will get the maximum sub array sum in order of n time. So see the difference from order of n cube to order of n. So this is a big improvement if I will get. So if I say I have to process 1 million elements, so it will always take the same amount of time. So order of n is very fast, and if I take multi-threading and all that stuff into the account, this the time taken by the program will be very low. So that's how that's the name of this algorithm. So let's see what happens in this particular thing. Let me just clear this particular thing. Okay, so what this algorithm says is we'll have two variables. First is current sum or temporary sum, which will be initiated as 0. Then, so sorry, my handwriting, pardon my handwriting, but this is current sum or temporary sum if you want to take a logical name. So temporary sum, and then I have the best sum or the best particular thing or the best sum that I have received so far, which will be initiated with a negative number or a big negative number. Let's say negative infinity to be precise. So I take as a big negative number to this. I will explain why I have taken this particular thing. So now what I will do is I will take one by one. I will take each and every element and I will add this particular element to this particular current sum. So for each element, let's say the element is I will add that particular element to the current sum, and I will check if the current sum is greater than, or sorry, if the best current sum is greater than the best sum or not. So initially the best sum is minus infinity, and if I take the first element and I add to this current sum, the value I will have is minus 2. So minus infinity is less than minus 2. So yes, this is the case, because in negative numbers the bigger negative numbers are smaller than the smaller negative numbers. So basically this is a very interesting thing to notice when I was in my elementary school. So here a negative infinity is smaller than negative 2. So the best sum will be given the value of minus 2, right? So this was the first iteration, and I will check if the current sum is greater than or equal to 0 or not. So if the current sum is greater than or equal to 0, then it is no case. There is no big deal. But if the current sum is not greater than 0, in this case it is minus 2, I will again initialize the current sum to 0. So why it will this is the case, I will explain it in the while I am implementing the logic. So if I implement this particular thing, so what I am doing is I am basically checking if I include this particular element. Let's say I am processing if I am processing this 4. So what I am checking is if I include this particular element into the current sum, does my value increase or not? If that particular value increases, then is it is it good enough to beat the best score or best sum? If it is good enough, then we will replace the best sum, else we will try it again. So that is the logic. So basically whatever, let's say I have in some process at some stage I get a best sum of 10, but after some iteration, one or two iteration, this best the current sum value reduces to 7. So I have to somehow save this particular 10, right? This is why we have used best, and to get all the permutations of the sum values, I am using this particular current sum variable. So and this particular logic is this particular algorithm is known as Kadane's algorithm. So this is all this thing is done in just single iteration. So at the end, I will, whenever I am processing the last element, that is the end of the algorithm, and after this particular element is processed, I will have the answer of the best sum or the best sub array sum. So let's code this particular logic, this particular Kadane's algorithm, and we'll see what happens. So first of all, I have to take the best sum, which is in this case I have to take float of infinity. So this float of infinity is nothing but the large negative number, so which is minus infinity. And I will take current sum equals to 0. So this is the temporary sum or the concurrent sum, also not concurrent sum, the current sum which is in the process. Now I will take each element one by one. So I will take from I for I in nums, and I will process current sum plus equals to I. So I am adding this particular element to the current sum, and I will and then I will check if this is enough to beat the actual best or the current best. So I will write current best, current sum. So what I'm checking is if this particular current sum value is good enough to beat this best sum. So this is best sum, and if it is good enough, then it will be automatically replaced. So this max function will return the maximum of the two items. Similarly, I will check if this current sum is greater than or equal to 0 or not. So for that, I will simply use the max function again, and I will check if current sum is greater than or equal to 0 or not. So if this whatever the max value, so if this current sum is negative, then 0 will be returned, and if it is greater than 0, then the whatever the value. So basically we are changing nothing if the value is positive, and if it is negative, then I will be basically initializing it to the initial state, which is 0. So this is all in the logic. So the current Kadane algorithm seemed very big and very tricky thing to understand, but if you understand it thoroughly, it is very easy to implement as well. And this will hardly take 2 minutes or even a single minute of your time whenever you are in a placement interview or placement round. And at the end, I have to return the best sum to the logic. So if I run this thing on the test case, let's see what happens. So for this array, the sum is okay, accepted. Let's go to this trivial example. So the trivial example is this particular thing, nums of 1. So if I give only a single element as an input, let's see what happens. So again, accepted. Let's take this particular example, minus 10,000. Oh, sorry, minus 1 lakh. Let's see what happens in this case. It should be the return output as only, because the best I have to take the sum or the maximum value I have, maximum sum value I have in the particular array only. So this thing is working. Let's submit this thing and see if it's good enough to beat the online submissions. So yeah, so if I see in runtime, it is beating almost 78 or almost 79%, if I to be precise, of online submission in time complexity, and in space complexity is almost beating 94%. So this is a very good thing and a good logic to implement. So this is Kadane. So most of the guys who are posting videos on this particular problem, they are using Kadane's algorithm only. So the these codes might be some different because of the variables that they are using, right? So if some of the guys are doing it in only one variable, then their their memory usage will be less than 100%, and their efficiency will be more than 80%. So that depends, but your code will be submitting at the end of the day. That is more important. Your logic is always analog in, so that doesn't matter if your it takes a millisecond more or millisecond less, to be precise. So that's all in this video. Take care of your health. Keep liking, keep sharing, keep subscribing this channel. If you have any doubt, you can ask in the comment section. You can ask on me. You can ask me in the Discord channel as well. You can join that. The link is in the description box. You can contact me in my Instagram, Twitter, LinkedIn. I'm available all online all the time. So take care and have a nice day.